Hey everyone, welcome back to the channel. So in the previous video, we learned that data in machine learning is stored in the form of matrices. And now in this video, we will see how that data is transformed, computed and processed using the matrix operations. And the matrix operations like addition, subtraction and multiplication are the backbone of all machine learning models. So let's break them down step by step and understand how they actually work behind the scenes. So I will be starting first with the matrix addition. Okay. So we will first begin with the matrix addition. So in order to add two matrix, there is one condition, and that condition is the dimension or the shape of those two matrix must be same. So let understand it. So I am writing here one matrix containing the element A11, A12, A21 and A22. So this is the first matrix, that is matrix A, and this is the second matrix, that is containing the element B11, B12, B21 and B22. So the shape of these two matrices 2 cross 2, and here it is also 2 cross 2. Why 2 cross 2? Because the first 2 represents the number of rows and the second 2 represents the number of columns. So here this is the square matrix and the number of rows and the number of columns are same. So the shape, okay, the shape is 2 cross 2, so it must be equal to the shape of the matrix B. The shape of the both matrix A and B must be equal, then and only we can perform the addition. So now let me add these two matrix A plus B. So in this case we have to add this corresponding entries. So I will be adding A11 with B11, A12 with B12, A21 with B21 and A22 with B22. So it will be like this: A11 plus B11, A12 plus B12, A21 plus B21 and A22 plus B22. So this is the resulting 2 cross 2 matrix that is obtained by adding this two matrix A and B. So let's understand it by an example. So suppose, let me draw one matrix here. It contains element 1, 1 and 2 minus 4. This is minus 1, 6, 0, 1. So if I want to add these two matrix, it will be here, it will be add with this corresponding entry, that is 1 plus minus 1. Okay, 1 plus minus 1, then this will be added with 6. So this is 1 plus 6, then 2 plus 0 and minus 4 plus 1, that is 2 plus 0 and minus 4 plus 1. So the result will be 1 plus minus 1, that is 0, 1 plus 6 will be 7, 2 plus 0 will be 2 and minus 4 plus 1 will be minus 3. So this is the matrix obtained after adding the two matrix. Now let us understand the properties of the matrix. So the matrix addition is both commutative and associative. So what is meant by commutative? So let me write commutative property. Okay, so matrix addition is both commutative and associative. So that is, commutative means when we add a real number, okay, 1 plus 2, that is equal to 2 plus 1. This means we change the position of this number in the RHS. Okay, so 1 becomes last and 2 become first, so it will be same, 1 plus 2 equal to 2 plus 1. Similarly, in case of matrix addition, when we add two matrix A plus B equal to B plus A, so that's why we call matrix addition is commutative. Now coming to associative property. So in case of associative, if we add the real numbers, okay, 1 plus 2 plus 3, that is equal to 1 plus 2 plus 3. Now if I add 1 plus 2 and after I add the result of 1 plus 2 plus with 3 is equal to the sum of 2 plus 3 plus 1. Okay, if I first add this 1 plus 2, then I add it with 3 is similar to adding 1 to 2 plus 3, the sum of 2 plus 3. So similarly, in case of matrix, when we add 3 matrix, that is A plus B plus C equal to A plus B plus C, then the sum of A plus B with C, okay, sum of A plus B with C is equal to sum of A plus, sorry, is equal to A plus sum of B plus C. So this is why it is called the associative property. So now coming to matrix subtraction, so there is a similarity between matrix addition and subtraction. So what is that similarity? So this is a similarity of the condition. Okay, so in order to perform the matrix subtraction, the shape or the dimension of the two matrix must be same. So this is the 2 cross 2 matrix and this is also a 2 cross 2 matrix. So now in order to perform the matrix subtraction, you need to subtract each element of matrix B from the corresponding elements of matrix A. So this is like, let me write it so you can understand it well. So I want to subtract B from A, that is A minus B. So the resulting matrix will be A11 minus B11, then A12 minus B12, and A21 minus B21, A22 minus B22. So the resulting matrix is also 2 cross 2. So let us understand it with the real world example. So suppose there are two matrices. Suppose this is matrix A. This is 1, 0, 2, minus 3, and a matrix B. which is -1 6 0 1. Now I want to perform the matrix subtraction, that is A minus B, which is equal to 1 minus -1. So we will be subtracting this -1 from the corresponding entry, that is 1. That is 1 minus 1. That is another will be 0 minus 6. Then 2 minus 0 and -3 minus 1. So the result will be 2 minus 6, 2 minus 4. And this is also a 2 cross 2 matrix. So in the matrix addition, we have studied about these two properties, commutative and associative. So we have studied that this property is valid in the matrix addition. But let us study that, is this property valid for the matrix subtraction? Let us find out. So first I will be checking with the commutative property. So if I write for the real numbers, that is 1 minus 2 and 2 minus 1. So this real number, the subtraction of 2 from 1 is not equal to subtraction of 1 from 2. This is -1 and this is 1, so which is not equal. Okay, so the commutative property for this real number is not valid. Similarly, if I write A minus B, if I subtract B from A and or A from B, that is B minus A, is also not valid. So means is not equal to, okay, A minus B is not equal to B minus A. So this property is not valid. Commutative property is not valid for the matrix subtraction. Now let's figure out for the associative property. So if I write the real number 1 minus 2 minus 3 and here 1 minus 2 minus 3. So if I subtract 2 from 1 and after that I will, if I subtract 3 from the result of 2 minus 1 minus 2, okay, so this will be -1 minus 3, and here if I subtract 3 from 2 and if I subtract the result from 1, okay, so in that case 1 minus -1, this will be -4 and this will be 2. So this -4 is not equal to 2. So similarly, if we go with the matrices, that is A minus B minus C, and here I will be writing similarly on the RHS A minus B minus C. So suppose if I subtract B from A and then subtract C from the result, okay, so this is not equal to if I subtract C from B and if I subtract result from the matrix A. So this property, associative property, is also not valid. So in case of matrix addition, these two properties are valid, but in case of matrix subtraction, these two properties are not valid. Also, I forgot to tell you one more thing about the dimension of the matrix. So for example, we have studied that for matrix addition or subtraction, the shape or the dimension of the matrix must be same. So for example, if the shape of the matrix is 3 cross 3 and suppose the shape of the matrix A is 3 cross 3 and for B is also 3 cross 3. So we can perform the matrix addition and subtraction if the both matrix have same dimension. But suppose if any one of the matrix, suppose this matrix have 2 cross 3 and this matrix have 3 cross 2. In this case, we cannot perform matrix addition or subtraction. Now coming to scalar operation. So if I want to perform the scalar operation, I will be first starting with the scalar multiplication. So I can multiply any scalar value with the matrix. So for example, this is matrix A denoted by 1, 2, 3, 1, 0, 1. I can multiply any scalar value with this matrix. So I can multiply 2 with the matrix A. So that will result in 2 will be multiplied with each elements in the matrix. So this will become 2, this will become 4, this will become 6, then 2, 0, 2. So similarly, I can, if I want to divide by 2, okay, so we cannot do the matrix division, but I can multiply this matrix by 1 by 2. So if I multiply this matrix by 1 by 2, that is 2, 4, 6, 2, 0, 2. So it will be back to the original matrix. That is 1, 2, 3, 1, 0, 1. And if I multiply the scalar value, this is also the scalar value, that is 1 by 2. If I multiply 0 with the matrix 2, 4, 6, 2, 0, 2, so the resulting matrix will be the 0 matrix. 0 matrix of the same shape. So the shape of this matrix is 2 cross 3 and the resulting 0 matrix is also the 2 cross 3 0 matrix. Now, apart from scalar multiplication, I can perform the scalar addition. So suppose I want to add a scalar value with a matrix. So suppose this is the matrix A that is denoted by 1, 2, 3, 4, 5, 6, 1, 1, 1. I want to add a scalar value to the matrix A, that is 2 plus A. So I will be adding 2 with the all elements of the matrix. So this will become 3, 4, 5, then 6, 7, 8, 3, 3, 3. So in this way we perform the scalar addition, and if I add 0 plus A, so the resulting matrix will be A only. Now coming to matrix multiplication. Let me draw two matrices here. A containing the elements A11, A12, then A21, A22. Similarly, the matrix B contains the element B11, B12 and B21, B22. Okay, so I want to multiply this two matrix, that is I want to perform A dot B, that is A11, A12, A21, A22. Similarly, B11, B12, B21, B22. So if I want to perform the matrix multiplication, so I will choose the elements of the first row and elements in the first column of this matrix. So the resulting matrix, the first element of the resulting matrix will be, I will multiply A11 with B11 and A12 with B22. Okay, and I will do the sum of these elements. So this will be the first element, that is A11 B11 plus A12 B21. Similarly, for the second element in the matrix, I will choose the first row and the second column. So I will multiply the elements in the first row of matrix A with the element in the second column of the matrix B, and I will do the sum of that, same as I have done for the first row of matrix A and the first column of matrix B. So I can write it as a A11 B12 plus A12 times B22. Then this will be, I will be considering the second row now. Second row of matrix A and first column of matrix B. So this will be A21 B11 plus A22 B21. Similarly, I will consider the second row of matrix A and second column of matrix B. So I will multiply the elements in second row with the elements in the second column, and then I will do the sum of those. So this will be A21 B12 plus A22 B22. Now there is one condition here. So we understood that how the matrix multiplication works, but can we multiply any two matrices? Then the answer is no. So in that case, there is one condition. So in order to multiply any two matrix, suppose the shape of the first matrix is 2 cross 3 and the shape of the second matrix is 3 cross 2. So in this case, here the first element denotes the number of rows and the second element denotes the number of columns. So suppose this is a matrix A and this is the matrix B. So in this case, the number of columns of matrix A must be equal to the number of rows of matrix B. So if these two elements are equal, then and only we can perform the matrix multiplication. So let me explain you once again. If the number of columns of matrix A, that is the number of columns here 3, is equal to the number of rows of matrix B, that is also the 3. If both this number of columns and number of rows are equal, then and only we can perform the matrix multiplication, and the resulting shape will be the number of rows of first matrix and number of columns of the second matrix. So resulting shape or the resulting dimension from the matrix multiplication of A cross B will be 2 cross 2. So let us understand the real world example. Let me sketch out one matrix here. So it is 1, 3, 5 and 2, 4, 6. And this is the another matrix 1, 2, 3. So the shape of this matrix or the dimension of this matrix is 2 cross 3, and the shape of this second matrix is 3 cross 1. Why? Here the number of rows are 2 and the number of columns are 3, and here the number of rows are 3 and the column is 1. So in this case, the shape of the first matrix is 2 cross 3 and the shape of the second matrix is 3 cross 1. So the number of columns of the first matrix is equal to the number of rows of the second matrix. So we can multiply these two matrices, and the resulting dimension of the matrix is 2 cross 1. That is 2 cross 1. So let us multiply and understand if it is really 2 cross 1 or not. So let me draw this matrix once again. 1, 3, 5, 2, 4, 6. And the resulting matrix is 1, 2, 3. So if I multiply the first row with the first column, so if I multiply the elements in the first row with the elements in the first column and do the sum, so it will be 1 times 1 plus 3 times 2 plus 5 times 3. Similarly, I will choose the second row and the first column. There is only one column, so only the first column. So here the operation will be 2 times 1 plus 4 times 2 plus 6 times 3. So the result is 1 plus 6 plus 15, that is 2 plus 8 plus 18. So the result is 22 and 28. So the dimension of this matrix is 2 cross 1. Now we will study about the properties. So first we will check about the commutative property and we'll figure out that if the commutative property is valid for matrix multiplication or not. So for the real numbers, that is 2 cross 3 is equal to 3 cross 2. So in case of real numbers, the commutative property is valid, but in case of matrix multiplication, it is not valid. Why it is not valid? So let us understand. For example, we have the matrix A having the shape 2 cross 3 and matrix B having the shape 3 cross 1. So in this case, A dot B is valid because the number of columns of matrix A is equal to the number of rows of the matrix B, the condition that we have studied earlier. So in this case, this condition satisfy and we can multiply A dot B. But in case of B dot A, the shape will be 3 cross 1 and 2 cross 3. So the shape of matrix B is 3 cross 1, and for the matrix A is, sorry, the shape of matrix B is 3 cross 1 and for the matrix A is 2 cross 3. So in this case, matrix multiplication is not valid because the number of columns of the matrix B is not equal to the number of rows of matrix A. So the multiplying matrix B with A, that is B dot A, becomes invalid. So in this case we can say that A dot B is not equal to B dot A. So the commutative property for matrix multiplication becomes invalid. So it is not applicable. Now for the associative property, if I write in this case, the result of A dot B with the C, matrix C, is equal to A dot the result of B dot C. So if I multiply matrix A and B and multiply the result with the matrix C is equal to multiplying matrix A with the result of B dot C. So associative property is valid in case of matrix multiplication. Now coming to the matrix multiplication having the distributive property. So for the distributive property, I can write A plus B multiplied by C equal to AB plus AC. So in this case, adding the sum of matrix A and B and multiplying C with the sum of A plus B, okay, is same as A dot B plus A dot C. Similarly, if I write C and A minus B in the parenthesis, which is nothing but equal to CA minus CB. So here the order matters. So this will be multiplied with A, C will be multiplied with A and C will be multiplying with B. So it will be CA minus CB. So now let's perform another matrix multiplication to understand more better. So this is 3 cross 2 matrix and this is 2 cross 2 matrix. So matrix multiplication is possible in case of this two matrix because the number of columns of first matrix is equal to the number of rows of the second matrix. So let me multiply here. So I will choose the first row and the first column. And the resulting shape of this matrix will be 3 cross 2. So the first element will be 2, 2 times 1, okay, plus 0. Then I will choose the second row. Sorry, second column of matrix, second matrix. So this will be 2 plus 0. Then choosing the second row of the first matrix and first column of the second matrix. So this will be 1 multiplied by 1 plus 1 multiplied by 1. Similarly, I will choose the second column. So 1 multiplied by 0, so this will be 0, and plus 1 multiplied by 3, this will be 3. Similarly, I will choose the third row of the first matrix and first column of the second matrix. So this will be same, 1 plus 1 and 0 plus 3. So the resulting matrix will be 2, 2, 2, 3, 2, 3. So the shape of resulting matrix is 3 cross 2. So the last matrix operation that we'll be studying is multiplicative identity. So in our previous video about the type of matrices, we have studied about the identity matrix. So for example, let me write out the identity matrix 1 0 0 1. So this is 2 cross 2. Then 1 0 0 0 1 0 0 0 1. So this is 3 cross 3 identity matrix. So this matrix is denoted by I2 and this one is denoted by I3. So identity matrix is a square matrix in which the diagonal elements are 1. Okay, we have studied this in the previous video. The diagonal elements are 1 and the rest of the element are 0. So now, as in the commutative property, we have seen that one multiplied by 3 equal to 3 multiplied by 1. So this is same. And in case of the identity matrix, suppose if I multiply the identity matrix with a matrix called A, so the result will be A. And similarly, if I multiply a matrix A with the identity matrix I, then also the result will be same, that is A. So now in this case, let us prove. So for example, we have a matrix called, or let me draw that matrix. So this is 1 1 3, then 0 1 0. So this is 2 cross 3 matrix, and suppose this matrix is denoted by A. So in order to establish the matrix multiplication, in this case the matrix I, okay, so it must have the number of, in the shape it must have the number of columns should be 2. Okay, so in case of identity matrix, so we can choose 2 cross 2 matrix. This is 1 0 0 1. This is the I2 matrix. So if I multiply I2 with A, we are checking this first condition. So this will be 1 multiplied by 1 plus 0 and 1 multiplied by 1 plus 0 here, 1 multiplied by 3 plus 0. In this case it will be 0 multiplied by 1 will be 0 plus 0, then 0 multiplied by 1 will be 0 plus 1, and the last element, that is 0 multiplied by 3 will be 0, and 1 multiplied by 0 will be 0. So the result will be 1 1 3 0 1 0, which is nothing but a matrix A. So hence we have proved that multiplying the identity matrix with A will result in the A, that is I dot A will be A. Now we will prove A dot I equal to A. Now let me write that matrix again, that is 1 1 3 0 1 0. So this is a 2 cross 3 matrix and this is the matrix A. Now I want to prove A dot I equal to 0. So in this case, this is A becomes the first matrix. In the above case, A was the second matrix and I was the first matrix. Now in this case, A becomes the first matrix and having the number of columns 3. So the second matrix also should have the number of rows as 3. So in this case, I will choose the 3 cross 3 identity matrix, that is 1 0 0 0 1 0 0 0 1. Why 3 cross 3? Because I want to multiply this two matrix and the condition should be valid, that is number of columns of matrix A must be equal to the number of rows of the second matrix. So that's why I choose the identity matrix, 3 cross 3 identity matrix, that is I3, and the resulting shape of the matrix will be 2 cross 3. So let us figure out. Here multiplying 1 with 1, okay, 1 multiplied by 1 plus 1 multiplied by 0 plus 3 multiplied by 0. Similarly, 1 multiplied by 0 plus 1 multiplied by 1 plus 3 multiplied by 0. Similarly, for the first row and the third column, that is 1 multiplied by 0 plus 0 plus 3, and same goes for when we choose the second row. Okay, so the answer is 0 plus 0 plus 0. Then similarly for the next element, it will be 0 plus 1 plus 0, and for the second row and the third column, it will be 0 plus 0 plus 0. So the resulting matrix will be 1 1 3 0 1 0. So the resulting matrix is same and it is 2 cross 3 matrix. So hence we have proved that I dot A equal to A dot I, and the result of both will be same, okay, will be equal, that is A only, and that's it. And that's how matrix addition, subtraction, and multiplication works. The building blocks behind almost every machine learning and deep learning algorithm. I hope you find this explanation simple and useful. If you did, then don't forget to like, share, and subscribe for more easy to understand AI and maths tutorial. Thanks for watching and keep learning.